Okay, so Tuesday night, last night, unfortunately I missed this little bottom piece of the notes about points of discontinuity, and I did not get a chance to go over these. So I'm going to go over a couple of those real quick, just so you can see how they happen. But we are still in section 5.2. We just need to discuss this little bottom piece right here. So if you have a function x squared minus 4 divided by x minus 2, this function is not what we call in lowest terms. And I know this because the x squared minus 4, the difference of two squares, is factorable. And I know that this x minus 2 and this x minus 2, because any quantity divided by itself becomes 1, these will cancel out, and my function will actually reduce to be just x plus 2. Now when we graph this, the graph of this original function is going to look exactly like the graph of just x plus 2. This is being linear, with a y-intercept of positive 2 and a slope of 1, y equals mx plus b. So y-intercept of 2, slope of 1. We can graph that line. However, our original function had some other pieces to it that we cannot just ignore. This bottom right here of x minus 2 in our original function has a limitation on it before it gets canceled, where if we were to go back to our original function, even though the graph would look the same as it does here, we have a restriction to our domain. X cannot equal 2. 2 minus 2 gives us 0, and 0 on the bottom of a graph is not viable. So even though we graph this where x is equal to 2 at, we are going to have to put an open bubble in our graph, because even on the straight line, x cannot equal 2. Oh, I'm sorry, I'm not on my camera. X cannot equal 2, so you have to include this bubble because that is a restriction to the domain. And usually you will just reduce it and then right after it say where x cannot equal whatever the restriction is from your original function. So let's take a look at another one. So here we have another function. We need to check to see if this is factorable, to see if anything can be reduced. This is, the top is still once again the difference of two squares. So this is going to break up into x plus 1, x minus 1 on top. And once you check for the factorability of this one, it will become x plus 1 and x minus 2. X times x is x squared. Minus 2x plus 1x gets us minus 1x. Positive 1 times negative 2 gets us minus 2. And so it is factorable, and these would be the two factors. So once again, any quantity on top and bottom will cancel as long as there's not any addition or subtraction here. And so your function will reduce to be this function, but you'll have to tell me that x cannot equal the restriction from this piece right here. x cannot equal negative 1. X also cannot equal 2 for this piece. So there are two restrictions to the domain, but you cannot overlook the negative 1 here from this part that cancels out. That's going to be a hole in the graph, not necessarily an asymptote. This x cannot equal 2 piece, this left over at the bottom of the function here, this is going to be an asymptote. But the negative 1 is going to be a hole in the graph. And that is what I did not cover on Tuesday. Once again, reach out to me if you have any questions or you need any help.